So there is another problem example that is your assignment that it's is due for next week. So next week until get I guess mm, Tuesday is good. Next week until 31, until the end of the month and end of the year, right? So I will discuss the problem, and I will explain you the objective function and constraints, and you should just uh, give me the code that in CPLEX. Okay. The problem is about the equipment of bike sharing stations with bicycle storage facilities, or as it is called, slots. These are the slots which bicycles are put into and locked into them. So there is three types of demand for them: 20, 21 stations, required facilities that had 7 slots. 31 of them, 31 stations required 12 slots, like medium facilities, and 41 stations required large facilities, okay, with 17 slots. And there's two types of facilities available in a warehouse. There's 20 and 30 bike storage units or slots. And the question is, how should we allocate the existing facilities to meet the required needs with minimal waste? We want to have the minimal waste. This is the kind of example that we have to first um, define and figure out the uh, scenarios. Okay, so we have to write down all of the possible scenarios for the problem. I'm going to simply tell you the scenarios, and you can try to just think on the writing of the code. Okay, so there is three scenarios, and there's two types of commodities. I'm sorry, there's two types of uh, slots for this one, right? So you have to just write down every possible scenario. So for 20 capacity slot and for 30 capacity slot, we want to write down all possible scenarios. The first scenario is for the 20 capacity is to like simply cut two of them and bring out two 7 by 7 slots. Like if you had something like this, you will cut this, you will cut this, and then you will have this one, which is 7 capacity slot. This also is a 7, and there is a residual type that is redundant that should be thrown out, maybe, which for this one is 6, right? After you have to just like try to add these ones together, and you have to just like reduce the other ones, reduce them to 20 from 20. So there's 6 residual slots for the first scenario, and you have to do this for all of them, and you will have these 8 scenarios, right? But we will not write this down in 1 to 8 in our model. the decision variable wouldn't be something like this. It would be something like uh, this. Why? Because we want to divide them into two parts. Xij is the proposed decision variable. And what does it say? The I represents the slot that we have. Is either is a 20 capacity or is a 30 capacity. So it chooses between these two, right? And the J is between these scenarios. That can be through 1 to 5. There's two ways for you. You can have J in here, that be 1, 2, 3, 4, 5, and 4 and 5 for the first one, for the 20 capacity, is simply 0, right? You can have this one right this, or you can have J and something like K, which puts J between 1 to 3 and K between 1 to 5, if you want to be more specific. There's no difference between them. There's the difference just the result, which for the if you just choose to write J, the amount of x14 and x15 will be 0. Okay? So the objective function, the decision variable is as I have told you, the objective function is to minimize the redundant cut pieces, right? What are these? How did we get these coefficients? These coefficients represent the number of unused slots for each of them, for each scenario, right? So for the first scenario, there is 6 redundant slots, which is a pretty high number compared to this one that has only one redundant slot. So in here, we have put these coefficients from this part. I'm sorry, from this part. And after that, you have constraints for your demand, right? And how did we manage to get them, extract them? It's really, really similar to the paper question. That, for the last one, you have what is the last one? You have x1, 3, x2, 3, and x2, 5. What is the mutual thing between these three decision variables? x1, 3, x2, 3, and x2, 5. 1, 3, 2, 3, and 2, 5. These ones all have 17. Which is the third demand, right? The large facilities, 17 slots, right? 41 stations demanded the large facilities. So this represents that one, the 17. Each of these scenarios that have 17 in them. And the other ones are really alike. So you have to write down the code for me and give me the result in CPLEX until next week, Tuesday of next week, and I will check them and I will give you the answers next week after 12 a.m. of Tuesday in Wednesday. And yes, this is all of the examples that could contain all possible challenges that I could think about. So if there's any other questions, please try to ask me through Telegram, email, or any other communication medias. Thank you.